Okay, here is part 2 of 3D figures, and it starts off with the cross sections shown above are from a rectangular prism. So I'm going to go ahead and draw in my rectangular prism. Okay, cross-section A is from a plane that is parallel to the base, cutting through the prism. Cross-section A has an area of 90 units square. Okay, so that cross-section there is basically this bottom. This bottom is A, and we know it's 90 square units, but we're not sure about its actual dimensions. We could guess if we wanted to go ahead and write out the factors of 90. We could do like 1, 2, 3, 5, 9, 10, and so on. Okay, we'll stop there for now. And then we go to cross-section B. It says it's from a plane that is perpendicular to the base and parallel to the sides of the prism, cutting through the prism. Cross-section B has an area of 50 units squared. So cross-section B would be like this side here. So I'm going to put a B right there. Okay, so, and then it tells me it is 50 units squared. So we can go ahead and write out some of the factors of 50, like 1, 2, 5, 10, and so on. Now we know that these cross-sections are going to share dimensions because they're all part of the same rectangular prism. So I'm starting to try to look for patterns as I write out their factors. Okay, cross-section C is from a plane that is perpendicular to the base and parallel to the front of the prism. Okay, so the front of the prism. Let me go back and label some stuff here. So A is this part down here. So that was A. And B was the side over here. B is this guy over here. And then C would be the front. And the front looks like this. And you guys know that the rectangular prisms can switch what the front is. So I was looking at it for a second like, oh, where's the front? Okay, so there's the front, and hopefully your rectangular prism, we want it to face to the right. Okay, so we're not looking for the one that's going up. We want it to be coming down to the right. Okay, and then the cross-section C has a squared units of 45 as its area. So go ahead and write out some factors of 45. So 1, 5, 9, 45, of course. And then we can kind of see some patterns, right? We've got 5, 9, and 10 up here. We've got 5 and 10 over here. And then 5 and 9 over here. So let's kind of see what we think makes sense. Let's start off with the sides. 5 and 10. If I gave the side B, if I gave it 10 here and I gave it 5 up here, let's see if that would work out with the front measurement. Well, it doesn't. It doesn't work out with the front measurement. So let's swap those, 10 and 5. And the front measurement, I'm going to make it 9 here. And so that leaves 10 as my measurement for the bottom there. So now whenever it asks us what is the length, well, the length is, this is a 9 by 10. We know that this is a 10 by 5. We now know that this side C is a 9 by 5. So the length is 9. The length, I'm looking at that here and here. The width is going to be 10, and we see that here, and then we also see it over here. And then the height is going to be 5. So my rectangular prism is not drawn properly, but that's okay. Okay, so here is a super, super duper tough one that I know I've gotten requests for, so let's go ahead and work this one out. All right, cross-section A, which I don't know why they're calling it cross-section A, and then they named a vertex on here, A. That's first part that I would change if I could change this problem. But we're looking for parallel to the base and half the height. Okay, so parallel to the base and half the height. Let me get a different color here and try to draw on this tiny picture. So we're talking about right about there. And what we need to do, all of these answers are in terms of perimeter or area. So that would make it a 12 by 9. But we got to multiply by 1/2 because it's half the height. So instead of it being a 12 by 9, and I'm getting that from here, 12 and then 9. So 12 times 1/2 would give me 6, and 9 times 1/2 would give me 4.5. So my new area would be 6 times 4.5. That would be my area. So I'm going to do some work up top up here. So area would be 4.5 times 6, 30, 27. Okay, so 27, and that would be inches squared, which that's not an option. So now we go to the perimeter. The perimeter of my new shape. It is a 6 by 4.5. We got those dimensions there. So in order to find perimeter, I would do 6 plus 6 plus 4.5 plus 4.5. And I would get 21 inches. Well, geez, that is not an answer option. So what we have to do is figure out we do have answer options that say perimeter of half the base and perimeter of 1/4 of the base. So maybe one of those is our answer. So let's find what the perimeter of the base would be. So we've got 12 plus 12 plus 9 plus 9. So 18 plus the 12 would make 30, plus 12 would make 42 inches. Okay, so 42 inches would be the perimeter of the base. 21 inches would be the perimeter of half the base. So we're looking to put this tile here. It's the perimeter of half the base. So this is going to be the half base answer. All right, let's move on to the next one. We're looking for the cross-section that goes through points A, E, and C. So let me get a different color. We've got A, E, and C. And let me see. Okay, I won't try to move it. Okay, so we've got to figure out, it obviously makes a triangle, but we cannot figure out what the perimeter of the triangle is because we don't know those diagonal lengths, but we could figure out the area. So you got to know the area formula of a triangle, which would be base times height divided by 2. And so base, it tells me, is 15, height of 8, and I'm seeing that here. It's pointing to the bottom, the base, 15, and this is pointing to the height, 8, and then we're going to divide that by 2. So in order to save time, I'm just going to use my calculator real quick and do 15 times 8. And we get 120, and of course if we divide that by 2, we would get 60. Okay, so 120, let me write that in, 120 divided by 2, and we get an answer of 60 inches squared. So that would be this tile here. We would have to move that here. Okay. It says it passes through points, I'm on the last one, I'm on this one down here, passes through points E and F and parallel to points A and B. Okay, I may have to move some stuff here. Let's see, how can I... Okay, look at that. All right. Okay, so E and F and parallel to points A and B. So E and F, let me get a color going. Go through E and F and A and B. So we've got... Okay, so passes through E and F, but parallel to point A and B. So we've got a triangle here. You can see the bottom, this dimension here, is parallel to A and B, and it is passing through E and F. E and F is right through the center. Okay, so we've got a triangle here. And so now we've got to figure out what the area of this triangle is, because once again we can't figure out the perimeter, so we know it's not that. So this triangle would have a base of 12, you can see that there, and a height of 8. And so that's my formula, base times height divided by 2. I get 96, 12 times 8 is 96, divided by 2, and that would give us an area of 48 inches squared. Okay, so that would be this answer here. So this one is 60 inches squared, and then this one is half the base of the perimeter, so that one goes there. All right, just one more problem. How many pairs of perpendicular faces does the shape below have? All right, this is a key word here, pairs. So we're looking for pairs. And perpendicular, remember, means one side's got to go straight down, one side is flat. So we've got this one here, and then this one here. I hope that you can see what I'm talking about. There's 3 there, and then there's going to be 3 on the back as well. So we get an answer of D6. All right, I hope this was helpful.